Okay. All right. So I want to talk about grams to moles and moles to grams. And the way that we like to talk about it in terms of conversions and changing things. So you have to have a conversion factor. Okay, and the conversion factor is the relationship between two items, for instance, miles and feet. Okay, so 1 mile is equivalent to 5,280 feet. So we can set that to a 1:1 ratio. So 1 equals 1 mile over 5,280 feet. That's fine. Okay. All right, now let's say we want to we have 5 miles and we want to find out how many feet that is. Typically we teach this in the following way. So I want to model 5 miles to so many feet. Okay, so I'm going to use my conversion factor, which is 1 mile, 5,280 feet, or the other way, like so. Okay. All right, so what we do is we start out with our 5 miles. And what we do is we use conversion factors and pick the one that has miles. You can think of 5 miles over 1. Okay, so what we're going to do is pick the one that conversion factor that has miles on the bottom, so the miles will cross out. And when you do that, you will get the following. Alright, and you end up with 5 times 5,280 feet, and you got the right answer because you know you got the right units. Okay, everything's fine and dandy. Alright, here's the problem. Does this make any sense? Alright, the point is, I'm telling myself, start with the conversion factor, so let me tell you what I did. I have a unit, and I have a relationship between unit A and B, okay? And what I'm going to do is multiply those two together and cancel out to get unit A. All right. Does that conceptually make any sense? All right. Does that tell me what's happening? What it's doing, it's giving me the right answer, but it's not really telling me what's going on. Okay, let's describe what's really happening here. Okay, the key is this, is that in 1 mile, okay, we have 5,280 feet. Okay, so what we can think of is a mile as a group. So this is a group. All right. And there's 5,280 feet in my mile. Okay, now what I'm saying is I have 5 of these. Each one each one of these, okay, so 5 miles, and each one of them has 5,280 feet, okay? So what you end up having is 5,280 feet 5 times. That makes sense? I think so. All right. I didn't use any kind of conversion factors that you can see of, all right? But I did, and it's right here. That's the ratio, okay? Instead of using a conversion factor, what I'm going to use is something called a grouping size. Okay, and what the grouping size is, it groups the thing that needs to be grouped into our group. And in this case, the feet are being grouped into miles, like the ratio of 5,200 feet per mile. Okay. So we have 5,280 feet per mile. Okay, that also can be said as 5,280 feet in a mile, or 1 mile, right? Now, if you notice, this statement right here looks like that. There's 5,280 feet in 1 mile, right? See, this is inside 1 mile. This is in mile. Per basically means in a mile, in. So, this turns out, this ratio here is what typically is called a conversion factor. Okay. What I want to do is I want to get away from the conversion factors, because all that does is you cross things out, but it really doesn't explain what's happening. Using groups here, I'm able to explain what is going on. So let's talk a little bit more about groups. All right, so grouping. What's entailed in grouping? Well, what you do when you group, you take things that need to be grouped. Let's say I have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. So I have 20 things. All right, and what I want to do is I want to group them into groups of 5 per group. Okay, so this also means 5 in a group. Okay. Now, how do we do that? Well, you know, just if we just come up with the answer, we'll say, well, there's 4 groups of 5 people, all right? Yay. Okay, but let's talk about what we're going to do. Okay, so what we're going to do is we're going to take the 20 things and divide them up into groups of 5 per group. Okay, so let's do that. So what I have here is I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, oops, 5. Okay, there's a group. And so what I'm going to end up with is 1, 2, 3, 4. Okay, so I go from 20 things basically down to 4 things, which I call my groups. What we did is that we stuffed in a sense our things into our groups. Okay. And typically the way that we say this is we divide up into our groups, okay? Makes sense. So the grouping size is 5 per group. Okay, so let's go the other way. You know, let's say I want to ungroup. And again, I'm going to use 5 things per group. Or in a group. So let's say I have two groups, each with 5 things in them. And what I want to do is I want to ungroup them, all right? So how do I say that? Well, I'll just use that word. Ungroup out of each group, oops, 5 things per group. Okay, and so when you do that, you empty out, in a sense, okay? You empty out of the 2 groups, and you end up starting with 2 things and ending up with 10. Okay. All right, so we can do this with any kind of group. A group will always be, you'll always be able to identify a group if it has a per statement in it, or a ratio. Okay, and it turns out that every single convergent factor is a per statement. So this grouping method is another way of doing conversions. The beauty of this system is that it makes some sort of connection with conception, and you'll see with math and words. Okay, so what I'm going to do now is I'm going to come with a diagram that sort of gives show what's happening. All right, so when you group, what you do is you start out with a lot of things. In the case what we just had, we had 20 things. And then what you do is you group them, and so you end up with less things. So here's your group of 20, and then what we did is we end up having a group of 4. So things got smaller. This is smaller than this guy down here. Okay. And what's the difference between, or what makes it change, is the grouping size. Okay. So many things get grouped into smaller things, okay? You have less of the things. They're in there. The 20 things are in there, in the 4, but you only see the 4 things. Okay, so you go into. Now, if we look at what we're doing here, the way that this is drawn is that we go from big things into little things, we go up. And what we're doing is we're dividing our 20 things up. We're going up here we're shoving them in the little container up here into groups of 5. Okay. All right, so this diagram and the words and the numbers are a way of expressing what is happening here, right? So what we're doing in terms of words, and this makes sense. You can go to anybody, probably anybody out there, and say, hey, I have 20 things. I want to get them into groups of 5. And then you would tell them, here's how you do it. You take the 20 things and you divide them up into groups of 5. Without doing any math, I'm pretty sure most people can do this type of thing without going, oh, I haven't had calculus 1. Or algebra 5, okay? The key here is that the words make sense. But if you notice, we have a math word here. That's the trick here. Also, we're doing up, and we're getting smaller, into. All the words relate to the math. Into is a word that we use often when we talk about dividing. So when we do these when we do this type of grouping, we divide up into. Okay, so this I call a grouping triangle. And the grouping triangle will always be based as this. The things that need to be grouped, the grouping size, and the group. The key is to find out which is which is the thing that's being grouped and which is a group. All right, now if we go back to our, well, if you could look at this, and if you get a statement like this, 5 things per group, the denominator is always the thing that you're grouping into, okay? It's like 55 things in the group. And the numerator is the thing that you're grouping. Okay, now, this is so, conceptually we want to make this make sense. We don't really want you to have to memorize this. It should make sense. Okay, so let's continue with the grouping. So I'm going to do the same type of grouping with the with the 5 things per group. And I have my things to be grouped. And then I have my groups. Okay, so let's go the other way. Let's say I have 10 groups. And what I want to do is empty them all out. Okay, so what am I going to do? I'm going to empty out of, and in fact, you can think about it, it's the way the diagram is that we're going down. So we can say down out of 10 groups, 5 things per group. So we basically do 5 things, empty 5 things, 10 per group, 10 times. And we end up with 50 things. And what do we do here? We multiply. So another word you could use here is multiply, undivide. Okay, you could use multiply down out of 10 groups. You get out of. Key word here is out of, and that relates to math. So in this diagram, what we have are keywords that relate to the diagram and to math. We have in and to and up. Let me do this way. Up, into, and that's divide. And then we have down, out, of, or from, for multiply. The diagram shows us that we're going up to divide, and we're going into, and what we're also when we ungroup, we go down out of the groups, and we get many from them, multiply. Okay, so let's try like a real example we might see in science. A real simple one. Let's say milliliters and liters, and I will do a conversion factor first and explain it the way we do in conversions, and then I'll talk about in terms of groups. And listen to the words and see if they make sense. Don't worry about the answer. All right. So let's say I have 5,000 milliliters, and I want to know how many liters that is. So what I need to have is I need to have the conversion factor. So I'm doing conversion method first, and then I'm going to do the group method. So I need the conversion factor. So there's 1,000 mils per liter, or the inverse. Okay, it's conversion. All right, so I'm going to take 5,000 mils. I picked the one that has mils on the bottom because I want the mils to cross out. And then do my math, and I end up getting 5 liters, which is the right answer. Okay. Now, when I did that, did it make any sense conceptually? Did you hear me talking about what I'm really doing? No, you really don't hear what I'm doing. Okay, now what I'm going to do is I'm going to change this to groups. Okay. All right, so here's my grouping triangle, and I'm going to call it my mil to liter grouping triangle. All right. Okay, so what's my group? Well, this is my group because there's 1,000 mils in a liter. Okay, I know that. So if I have 1 liter, there's 1,000 mils inside it. All right, so liters are going to be my group. Milliliters are my thing to group, and then my grouping size is 1 liter. Okay, and so what I want to do is I want to have, again, I start out with 5,000 milliliters. All right, so what I'm going to do is I'm going to divide 5,000 milliliters up into groups. So divide 5,000 milliliters up into groups of 1,000 mils per liter. So I have 1,000 of these guys, okay? And then what I'm going to do is break them up into thousands. So I divide up by 1,000, and I end up getting 5 liters. So you go from 5,000 things down to 5 things. Each one of those 5 things will have 1,000 milliliters in it. Okay, so we can use the grouping triangles instead of conversions, and they make sense. Right, now let's go the other way. Let's see how it makes sense that way. Now let's say I want to go from, I have 8 liters, and I want to know how many milliliters that is. Same grouping triangle. And I'm given 8 liters. Okay. So what I'm going to do is take 8 liters, and I'm going to empty out, down, I'll use down because that's the direction I'm going, down, out of each one 1,000 mils per liter. Okay, so I'm going to do 1,000 mils 8 times. And so I end up with 8,000 mils, which makes sense. I'm just opening up each liter and emptying out 1,000 mils. So I end up having 8,000 mils. Okay, so what we have now is we have a chance to use marry, I'd like to say, concept with math by using a diagram schematic and words. The words are important. I just don't want to say times and multiply, cross out, have the units. The words have got to connect. The words have got to connect with the math. The diagrams got to connect with both. That's the key. All right. Now, the next video, what I'm going to do is I'm going to use this for some simple chemistry, particularly moles, to number atoms and molecules, and also grams to moles, and moles to grams. That's how we usually say it in terms of conversions. But we have to be careful about our words because we want to make sense. We just don't want to do math. We have to make sense in terms of our actual words and math. Okay.